All right, welcome. We're going to talk about the intermediate value theorem today. It's a very important theoretical result, and people use it numerically in many ways to solve equations. All right, so there's an easy picture that goes along with this theorem. Suppose you have a continuous function, f, and it starts out here for this x value, and this y ends at that x value. So it starts out at this height, ends at this height. Suppose you have some y that's in between sort of the starting and value, ending y values. And if you draw this dotted line, because f is continuous, it has to cross the graph somewhere. There can't be a gap in f, which means that there's an x somewhere between a and b, so that f of x is y. That's all the theorem says. So here's the statement. Intermediate value theorem. It says if you have f continuous on the interval ab, and if you have some y that's in between f of a and f of b, then there's an x in between a and b, so that f of x equals y. So it's really just saying you can solve the equation f of x equals to y. It doesn't tell you what the solution is, it just says there is one. Okay? So here's an example. Let f of x be x cubed plus x. Show there is an x somewhere between 1 and 2, so that f of x is 9. Okay? Is there an x somewhere between 1 and 2 so that f of x is 9? Well, first of all, f is continuous, right? It's made up of continuous pieces. And then we calculate the starting and ending points. F of 1 is 1 cubed plus 1, so that's 2. F of 2 is 2 cubed plus 2, so that's 10. And then, since 9 is between 2 and 10, the intermediate value theorem says there is an x somewhere between these starting values, 1 and 2 that we used, so that f of x is 9. So yes, there is an x somewhere, at least one, so that f of x is 9. All right. Now, the most important corollary of this is the following. Corollary is just a word that means kind of easy theorem that follows from another theorem. Again, you have to have f being continuous on a and b. If, how did I phrase this? 1 of f of a and f of b is negative, and the other is positive, well, if one value is positive, one value negative, then 0 is between them, and therefore the intermediate value theorem says then there is an x, at least one x, in between a and b, so that f of x is 0. So a lot of math problems you can rephrase the problem so you're solving an equation equals to 0. Okay? So this is actually usually how the theorem is used. So for instance, if f happens to be the cosine squared of x minus 2 sine of x over 4, show there is an x somewhere in between 0 and 2, so that f of x is 0. By the way, when this happens, people write or say x is a 0 of the function. Okay. Anyway, show that there's a 0 of this function somewhere between 0 and 2. So first of all, for the solution, you would say, well, f is continuous. And that's because it's made up out of continuous pieces. And then you would evaluate it at the endpoint. So f at 0 would be cosine squared of 0 minus 2 sine of 0 over 4. So cosine of 0 is 1, 1 squared is 1, and sine of 0 is 0, so the answer is 1. Then f of 2 will be cosine squared of 2 minus 2 sine of 2 over 4. Now no one knows what the cosine of 2 is, so you have to approximate it on a calculator, and you get negative 0.786. So as one value is negative and the other positive, the intermediate value theorem says there is an x. Actually, it's a corollary. Well, it's the intermediate value theorem. There is an x somewhere between 0 and 2, so that f of x is 0. In other words, that function has a 0 somewhere between 0 and 2. All right, that's it. Ciao.